All right, welcome back. This week we're going to focus on UN Sustainable Development Goals number 7 and 13, affordable and clean energy and climate action. Now, as we've talked about in previous weeks, clearly these are related to a lot of the other goals, and some of your readings have these tied to a number of different ones. Ones I want to emphasize today are the two that we have. First of all, 9 and 11. They're clearly tied to industry, innovation, and infrastructure. You have to be able to support the infrastructure for renewable energy sources, to improve energy efficiency and make some gains toward climate. And second, affordable and clean energy is really a part of green cities and communities. Green buildings often integrate solar panels as a part of them, and I think this is really a key link. Climate action, I would link to life below water and life on land. Clearly, we're helping humanity to preserve our own skins, but we're also protecting the other organisms that we share the planet with. So this is a clear link with these sort of things. I'm going to focus more on energy because energy is kind of tied to climate with this, and we'll look at specific Sustainable Development Goal targets. By 2030, ensure universal access to affordable, reliable, and modern energy services. So not just develop these and have these available for the wealthy, but also have modern energy services and modern renewable energy sources be affordable. By 2030, increase substantially the share of renewable energy in the global mix. Really, really important, and we'll talk about a number of possibilities for this. By 2030, double the global rate of improvement in energy efficiency. I'll talk a little bit more about this later in our slide. And then enhance international cooperation to facilitate access to clean energy research and technology, including a variety of different things. Things like renewable, where we ultimately want to get to energy efficiency to make the most use of the energy we have, and advanced and cleaner fossil fuel technology. This is not a solution long term because it's still relying on fossil fuels, but it's kind of a step that will help us to get there. Implementing the cleanest version of the fossil fuel technology that we have while we are developing renewable energy certainly is a way to go, and it's going to help us out. And then as far as climate sustainable development goals, strengthen resilience and adaptive capacity to climate-related hazards. Be willing to understand what needs to be done to withstand some of these extreme weather events and natural disasters that are climate-caused. Integrate climate change measures into national policy, strategy, and planning. So kind of plan for the future, plan with resilience in mind, plan ways that we're going to tackle that. A lot of corporations are planning to get to zero carbon emissions by 2040. Well, that takes some steps, and it's not that you're instantly going to flip the switch and have that happen. You need to be planning and implementing things now so that by 2025, you're a certain portion of the way there. By 2030, you're a little further. 2035, you're a little further. And then by 2040, get all the way to carbon neutral. So it takes planning. Improve education, awareness raising, and human and institutional capacity on climate change mitigation, adaptation, impact reduction, and early warning. So let people know, get them involved in the planning process. And then promote mechanisms for raising capacity for effective climate change related planning and management in least developed countries. So don't just do this with the wealthy in mind. Include the least developed countries, include small island states that are developing. And focus on women, focus on youth, focus on marginalized communities. Get that interdisciplinary approach to this and include that as a way of going about this to achieve a better world. The photo, I should mention that the photo is solar smart flower. It's a piece of technology we have right outside the Greer Center on the Virginia Wesleyan campus. It unfolds and it actually tracks the sun so that it can improve the energy efficiency by 40%. Improving energy efficiency by 40% is a really good thing, but with more moving parts, we've found that there's more instances where it would break down relative to normal solar panels. And so these are some of the challenges that we have. We have to weigh what are the advantages of new technology and more complex things with what are the disadvantages? What are the things that make it where if this is out of commission for several days, how does that decrease its ability to generate renewable energy? So it's a complex issue. This is bigger than I can do in one lecture and more in depth. I've given you a lot of different readings and a lot of videos today. And again, this just barely scratches the surface on what's available, but I wanted to keep it to a reasonable time frame. I want to focus on 3 different forms of energy. The first one is solar, and both of these photos are from some developments that have occurred in Japan on solar. Japan has really embraced solar since the nuclear disaster in 2011 and has really seen solar as an alternative to this. And so you all will have seen increased solar on rooftops, in these large-scale solar farms, and even floating farms. They've found that if you have kind of the water as a cooling mechanism underneath, that you can actually get improved energy efficiency. So this is one way that they can produce a lot of electricity and improve energy efficiency of the solar panels. Wind energy. This is the schematic of the Virginia wind installation. Currently, we have 2 demonstration turbines, and these are actually in federal water. So they are 27 miles off the coast, 43 kilometers. Each of these demonstration towers is 6 megawatts, so 12 megawatts in total. And these 2 combined can power 3,000 homes. So this was set up as kind of a demonstration phase 1 project to kind of work out all the bugs, make sure that we can do this, get the technology in place. It's a really long cable going from the offshore wind farm, but that's where the wind is highest. So you want to get the most wind generation. That's a good place to do it. The next phase in this will add 176 additional turbines, and these are actually taller, larger turbines that work out to 15 megawatts each. So you add up all of the energy generated by the 176 plus the 2 that are already in place, and when this is fully operational, it'll be able to power 1.3 million homes. So there's about 7 or 8 million people that live in Virginia. So this is a substantial amount of power for our state, and it's kind of a model for what can be done in other locations along the U.S. coast or other countries of the world. And then nuclear. Nuclear remains one form of alternative energy that does not release carbon as you are generating power. Now, if you look at life cycle cost, the mining operations, transportation, all of that releases carbon. And so we really have to take a life cycle cost approach, but the big advantage that it has going for it is that it's extremely energy dense. And so this schematic, 1 uranium pellet is equal to 17,000 cubic feet of natural gas, 120 gallons of oil, or a ton of coal. So clearly there's a lot of energy in this enriched pellet. We just have to figure out what to do with it when it's expended, and how to deal with the waste, and what to do if there's an accident, how to make sure that we prevent as many accidents as we can and minimize the effects of nuclear accidents. Ocean resources is the third one that I want to stress, and this is one that's not really considered a whole lot. There are 2 different forms of this. The first is tidal energy, and this is as the water comes in and out with the tides. In certain locations, it's more feasible than others, but having some sort of setup, whether it's like a hydropower dam that kind of works in both ways, or propellers that would capture the energy from tidal flow. This is a potential resource that is not really extensively tapped. And damming off an area to tap the tidal flow does impede boat traffic, it does impede fish migration and things like that. That is the highest efficiency, but there are other ways, such as the one depicted on the left, that might be able to capture tidal energy efficiently. The other possibility is the energy of wave action. As waves come on shore or even are offshore, you can get energy that's generated by buoys moving up and down, moving a pump, generating electricity, and then transferring that energy from an array of buoys, transferring that energy in toward the coast. They've even shown ones like this linear absorber with a hydraulic ram joint that kind of flexes back and forth, and that flexing will then turn a generator and generate power. The oceans are massive, and so there's potential for these forms of energy to be tapped, especially in certain places where the tidal flux is larger than others. Next, I want to focus on what we can do about climate actions. And so I've assigned this article, Top 10 Solutions to Reverse Climate Change. And as you'll see as you read the article, some of these are like educating women or reproductive control, providing access to birth control. And this is kind of this multidisciplinary way of getting at this, and it ties into how we've looked at how each of these sustainable development goals is related to several other of the climate goals and the sustainable development goals. So the article does that. What I want to do is focus on three things that are not really emphasized in these 10 solutions that Green America identified, which were in this book, Drawdown, from 2017, edited by Paul Hawken. So I want to talk about these things, but I want to emphasize three that weren't mentioned in that. One was sort of mentioned a little bit, but I want to talk about three of them. So the first is energy efficiency. This didn't even make their top 10 list, but it's one of the easiest things that can be done. Sealing air leaks, adding insulation. Just simply for about $300 US, you can add an extra layer of blown-in cellulose insulation to a typical attic and greatly increase your energy efficiency and greatly reduce heat loss. This is one that you just simply blow in. It's easy. A homeowner can do it themselves. You kind of spread it out and get it to be evened out, and then it kind of settles in the cracks. So it fills in around the existing insulation and adds to that. Improving the heating and cooling systems. There are some very efficient systems out there. So upgrading an old heating and cooling system is a good way to go. Or ground-based geothermal would be a complete overhaul, but even simply going from a lower energy efficiency unit to a higher energy efficiency unit is going to help improve your energy efficiency for your house. Sealing the ductwork, preventing heat loss or the loss of cool air from an air conditioning duct is a good way to do this. Replacing windows, you get really good improvements in energy efficiency, especially if they're very old windows. This is a good way to make a substantial improvement with kind of one fell swoop. And then simpler things that can kind of be rolled out as you go. Upgrading lighting, appliances, water heating equipment. Each of these is going to save you a little bit in money. So it should lower your energy bill. It should reduce the amount that you spend on that. And then with the cost savings, you can do the next upgrade. An energy efficient appliance, an energy efficient hot water system, things like that. And then finally, installing renewable energy systems. This is not really energy efficiency, but you're actually generating electricity or generating energy efficiency. It can be improved energy efficiency if it takes the place of something else. So if you were to take out an incandescent bulb system and then put in a solar panel that then charged a battery that then would light LED lights along the hallways in your house. That way you don't need to turn on the light in the evening, because the solar panel and the saved energy from the daytime is able to provide that for you in the evening. So that's one way it could be, but it's really more an alternative. Reforestation is something where you plant more trees, they can take up carbon dioxide from the atmosphere. As the trees grow throughout their lifetime, they're going to be continually sequestering carbon. And then as they die or shed their leaves, those can become, a part of them can be bound in soils. So this is a large tropical reforestation project in the Amazon basin. So that's why this area is subject to occasional riverine flooding from time to time. That's why you see the water in this particular one. But this particular project, they look to plant very dense plantings in small areas, and then many of the seeds will survive. And at least some of them, they've got 90% success in terms of getting good germination and lasting reforestation in some of these spots because of that approach. But it's not just tropical areas. Temperate reforestation is also critical. And this is one where it's kind of a common sense solution to a lot of things. So lumber companies owning an area where they're going to be harvesting the trees for wood, for lumber, they're going to want to plant trees in order to have then additional trees that can be harvested later on in time. But if this is done in a way that then allows for the sequestering of carbon into the soil, this can be a long-term solution. And reversing some of the deforestation that's occurring kind of sets this back to where the terrestrial ecosystems of the world are sequestering carbon. Another one that I assigned an article on is blue carbon storage. This is storage of carbon in oceanic habitats and through the growth of ocean plants. So as opposed to green carbon, which is terrestrial, this is blue carbon. So this can be seagrasses, underwater grasses, as you see on the right, growing, adding to the carbon that's in the sediments there. Marsh grasses, by planting marsh grasses, this allows for the plants to take up carbon dioxide from the atmosphere, and then they can store some of that in the sediments. In our area, we've lost about half of our wetlands, predominantly, which is salt marshes in our area. So planting more marsh grasses represent a way to sequester some of that carbon in sediments, grow new marshes, etc. They're very fast-growing plants. So this is a good way to sequester carbon. And then on the left-hand side, growth of mangroves in tropical areas adds to the biomass that's in there, builds islands, increases the carbon content of the sediments. So this is a potential. Before I gave you the article that had 10 ways, this is one that I put as optional, 101 ways to fight climate change. There's probably 1,001 ways, different things that we can do. And of the ones in this article, one of the reasons I made it optional is not all of these things are focused on climate change. These are all environmental things. These are all good things to do, but they're not explicitly focused on climate. They might be saving water or something like that, but they're not all climate. But really, we're going to need 101 things in order to fight climate change. It's that big and complicated of a problem, and many ways that we can move the needle, especially as technology improves. These are ways that we can reduce our carbon footprint.